Okay, so P11.3, and this is a problem. A cabin keeps the air pressure at 80% that of sea level. What is the force exerted on a window of area 0.1 meters squared at a height of 10,000 kilometers? And they give you this handy graph that looks like this. Okay, and that is an absolute stinker of a question. How do we solve it? Well, let's break it down. Okay, so the first thing we need to know is we need to know what is 80% of sea level. So I know what my pressure is. So if I know what my pressure 1 is, I know that sea level the pressure is 100 kilopascals, and I could read that off my graph here. 0 height, 100 kilopascals. So I know that that's that. So therefore I know that 80% of P1 equals 80 kilopascals. Okay, pressure 2, that's the pressure on the outside of the window. Well, I've said that I am at 10,000 kilometers, so I'll go up to 10,000, and I go along, and that tells me that pressure 2 is 20,000 kilopascals. So 20 kilopascals. So I want to know, so therefore, what I need to know is, I need to know what's the difference in pressure. If I know what the difference in pressure is, I know that I'm trying to work out the force. So therefore, I'm going to need to use the equation F equals P over A. If I know what the difference in pressure is, and I know what the area is, I can work out what the force is. So I'm going to do 80 divided by the area, which was 0.1, which means it's going to give me a force of 800. Sorry, I got that slightly wrong. I put my F and my P in the wrong place. So I know that pressure equals force divided by area, which means that force divided by 0.1 equals 80. So I want to do that times both sides by 0.1 to get rid of that 0.1 on the bottom here. So I get 80 times by 0.1 equals my force. So that means that my force is equal to 88 kilonewtons, which is 8,000 newtons of force. And the tricky bit is remembering that at a greater height you're going to have less pressure. The difference in that pressure will create a force, and if you know what the area is, you can work out what that pressure is, what that force is, sorry. So how much, because what you're doing there is you're saying the long way round of doing this would have been to do the force on the inside minus the force on the outside. That will give you your resultant force pushing outwards, okay? But if you just do the difference in pressure, that will give you the net force exerted by that pressure. Okay, next problem. The next problem I'm going to give you is one to do with hydraulics. It's an application of the things that you've learned so far, and it brings together about 3 or 4 different topics. So it's quite a tricky one, but quite useful. Okay, so if you imagine that you've got a car that's on a platform, and that platform is connected up to another platform, but this one here, and it's got a person standing on it. Okay, and this pipe here is filled with a fluid. Now it has to be a fluid because fluids can't be compressed, and because they can't be compressed, that means that the pressure is the same throughout the fluid. Okay, so whatever the pressure is here, and ignore the height difference because it's not big enough to make a big difference compared to how much it's going to be when you push into it. Okay, so whatever the pressure is there, it's going to be the pressure here. It's going to be the same as the pressure here. Okay, it's all going to equal out. So if you tread on here, you're going to push this car up. So if this car weighs 10,000 newtons and this person has a weight of 1,000 newtons, let's make it 100,000 on the car. Okay, versus 1,000 newtons for the person. This person can lift this car even though this car is 100 times bigger than them. Because watch, the pressure that they exert is equal to the force divided by the area. The force we know is 1,000. And if we say that that was 1 meter squared area there, then that pressure equals 1,000 newtons per meter squared. That's the pressure that he's applying there. Okay, and we know that that pressure will be the same as the pressure that the car is feeling here, because all of the pressures in the fluids is the same, because it can't be compressed, so the pressure is the same. So as you push down on here, it pushes down, push down, push down, push down. If you push down, it gets pushed all the way through. So that means that this pressure is the same, so pressure 1. So that's pressure 1, force 1, area 1, which is that force, that area, and that pressure. And we know that P1 is equal to P2, which equals force 2 divided by area 2. Where force 2 is the weight of the car, and you know that that's 100,000. And you know that the area, so you know that P2 is equal to 1,000. And what you're trying to work out is you're trying to work out what the area is. So you know that the area is going to be equal to 100,000 divided by 1,000. Cancel out my zeros. So area 2 equals 100 meters squared. And that makes sense because that area would have to be 100 times bigger than this area in order for a person that weighs 100 times less than the car, for those two forces to be balanced, okay? And that's why this hydraulic system is known as a force multiplier. Just the same as the moments and the levers that you did previously. This is another example, and they can combine levers, gears, hydraulics all together. But once you've got the hang of it, it's fairly straightforward, because all you're doing is applying this one equation, pressure equals force divided by area, and remembering that the pressure is the same throughout in the pipe. Okay, if you remember those two things, they can't catch you out. The pressure will be the same because the liquid can't be compressed. If the pressure is the same, then the ratio of the force divided by the area must be the same, and then you can work it out from there.